Good morning, everyone. Right, this is Damian, and for today, okay, I'm just going to run through a very simple H2 mathematics topic called inequality. There'll be definitely more than one part, okay, to this video, okay, because for today, again, I'm just going to run through something that is pretty straightforward, and hopefully, right, if you are actually able to understand, right, bit by bit, then you should start to progress on, right. Otherwise, okay, for today, right, we're actually just going to try out, okay, this couple of questions over here. So first question, okay, we have our very standard, okay, quadratic inequality. Now, quadratic inequality is of course something, okay, that all of us have already learned how to solve, right, in our secondary school, right, or our IP, right? So there are various ways taught, right, by school teachers definitely. Okay, so for today, okay, I'm just going to run through the most standard way using a graphical approach, right? So graphical approach is pretty simple, right? You simply just draw the graph, okay, and right, start solving, okay, the equality, right? So of course, right, to sketch the graph, right, as usual, you need to remind yourself, okay, that based on the quadratic inequality, right, the coefficient, right, of x squared, right, is actually equal to positive 1, right? It is positive, right? So what it means, okay, is that when we do draw the graph out, okay, we are expecting to draw a happy face graph, right? So happy face graph right over here, right, x-axis, right, and of course the graph is expected to cut the x-axis, okay, at 2 points, okay, or the roots of it, so at -4 and -1. Now you notice that when we actually solve inequality, right, okay, using graphical approach, we do not need to actually sketch the y-axis, right, because honestly it doesn't actually help, right, eventually, right. So we just need, okay, the values here on the x-axis, right. So for y-axis, okay, just leave it aside, and from here, right, once you've drawn the graph, the happy face graph, right, just do what we've been taught, right, shade the region, right, that is actually below the x-axis. Okay, how would I know? Well, if you were to read the question one more time, right, we're actually solving for lesser than 0. So lesser than 0, right, in plain English means that, I will actually want the part of the graph that is always lesser, right, than, right, 0, or in other words, okay, below the x-axis, or if you want to, right, the values of the graph whereby the y values are lesser than 0, right. So I'm just going to put it very simply, anything that's actually lesser or below the x-axis, right. So from here I can actually now, right, write down the solution, right, for this inequality, right, x being -4 and 1, right. So that's it, done already, completed, right. So we're going to move on to get to the next question already. So for the next question, right, again, we have another quadratic inequality, right? So remember, right, you can always pause the video first before I actually start, okay, the question, okay, so that if you want to, you can try out first. And at any time, right, you are start, right, just play the video, and hopefully, okay, when you have actually listened to the part, okay, that I have helped you, right, to where you got stuck at, you can actually just pause the video again, right, and continue a bit on your own, right. So remember this one, yes, it's a video recording, but right, don't try to use it as though it's like you're learning from a lecture, right. So anyway, right, let's take a look at question number 1b, right. So as I said, okay, another quadratic inequality. So what is the difference between 1a and 1b? Okay, is that for 1a, right, the quadratic expression is, factorized for you nicely already, right. So for 1b, as you can see, it is not factorized, okay. So of course we will want to factorize it, okay, so that we can actually mark out the roots of the graph, right, properly. Okay, so over here, all right, you may, right, actually choose to solve this inequality, right, in non-exact form, right, meaning, right, you can actually always leave the roots in terms of decimal points if you want to. Okay, but not very often in tests, right, you realize that the question will actually always ask you solve the question exactly, right. So which means, right, all the roots must be in terms of, well, either whole number integer or surds, right. So how would you actually know, okay, whether the roots are actually very nice, giving you nice whole number integers or not, right? You simply just need to actually investigate, right, with your calculator, right. So all our calculator, right, have a basic function, okay, of solving for polynomial, right, equations, right. So just right solve, right, using a GC, right, and take a look at the nature of the roots, right. So when you actually investigate, okay, with your calculator, right, you will actually be able to see whether the roots are actually either whole number, decimal points, or of course even imaginary roots, right. So if it is imaginary roots, right, so if the calculator give you imaginary roots, right, it simply means that, okay, the quadratic inequality, right, is actually not factorizable, right, in terms of real number, right, or real factors. So otherwise, okay, if it's a whole number digit, right, or fraction, right, whole numbers or fractions, right, or even decimal points, right, you need to tell us that, oh, you need to tell yourself, okay, that the quadratic expression, okay, is indeed factorizable already, okay. So it's really up to you, okay, but ultimately, right, you should realize, okay, that by now, right, the quadratic factor is indeed, okay, giving you decimal points, okay, as the roots. So what it means, okay, is that if we need to really solve this exactly, right, we have got to find a way to solve for the roots first, okay, the exact root first, okay. So of course, right, what I am proposing is you use the quadratic formula, right. So I'm going to actually ask us to actually consider the quadratic factor, right, sorry, the quadratic equation of x squared minus 4x plus 1 equal to 0 first, right, to solve for the roots. So you apply your usual quadratic formula, right? Negative b plus minus, right, b squared minus 4ac, right, over 2a. Okay, so of course, okay, I have actually skipped the part, okay, whereby, you know, you square, okay, a negative number, right, and it becomes positive and stuff, right? So ultimately, right, you realize that the discriminant, right, is going to give you a square root 12, right? So that actually explains why we don't have exact roots over here. Of course, root 12, okay, is something that you can actually simplify further by using a bit of rules of indices, right? Root 4 multiplied to root 3, right? And you actually get two very nice roots, right? 2 plus minus root 3. Okay, so these are actually the two exact roots. So once you have the exact roots, right, as usual, we're actually going to progress, right, push on rather, right, to our graphical approach already. Right, so x-axis, right, happy face graph again, right, for obvious reason. Put in the two roots, right, the smaller root first, right, followed by the larger roots. Okay, then as usual, right, sketch the region, okay, that you want. So again, for this question, we're sketching or rather solving for, right, lesser than 0. Right, so actually solving for lesser than 0 over here. Right, so we need to find the part of the graph that's actually below the x-axis, or in other words, the part whereby the graph have y coordinates that are lesser than 0. Right, so from here, right, we therefore again conclude that, boom, we have our solution already. So the exact solution, right, it's going to be given as such. Okay, so that's the end already, okay, for this part 1. Right, hope you've enjoyed it and see you very soon.